Hi, welcome back. In this lesson, we're going to be going on with calculating the gradient of a straight line. Now, this skill is going to come in handy in a couple of later lessons when we start to go a bit deeper into our Cartesian planes and our straight lines. But for now, we're just looking at calculating the gradient. Now, in our rule for a straight line there, we can see a few different things, and the one we're going to be looking at, the variable we're going to be looking at for this video is m, because m is equal to the gradient, or you could also call it the slope. But for now, I'm probably going to be using the term gradient, so just keep an ear out for that. Whenever I'm referring to gradient, I'm actually talking about this m value here. So just as an intro, let's pop that stuff out of the way. What we have here, this is our rule for gradient, and we calculate it as rise, which is our up and down, divided by our run, which is left and right. At its most basic form, essentially, this is what we're doing. So let's get an example in here that we can work with. Well, what do I know about this line segment? Well, I know it has a start point, so I'm going to put the start point here. And I'm actually going to label that point 1. We start counting from 1, so let's label that point 1. I also know that it has an end point, so I'm going to pick this end point right here, and I'm going to label that point 2. Now, rather than just having point 1 and point 2, I can be a lot more specific about where these points are actually located. And I can do that because we are on a Cartesian plane. So I'm going to use that to be able to accurately plot where point 1 and point 2 are. So I know that my x value for point 1 is actually -1. And I know that my y value coming down is actually -3. I also know that for point 2, my x value, well, that's 3, and my y value, well, that's 5. So my x value for point 1 is -1. My y value for point 1 is -3. But because I have two different points, I'm going to change this up a little bit, and I'm going to say x1 and y1. And I'm going to do the same with the other point, except this time it's not going to be 1 because I'm at point 2, so it's going to be x2 and y2. Now, if we go back over to our formula, this is where we can start to calculate rise. Now, our rise, it demonstrates the distance you have traveled along the y-axis from point 1 all the way along the y-axis until you are at point 2. And it is the distance you have traveled along the y-axis. So if we actually sit here and count 1, 2, 3, 4, 5, 6, 7, 8. From point 1 to point 2 along the y-axis, the difference is 8. So we're just going to go equals 8. Now, we're actually going to do the same thing for the run as well. And you've probably guessed it, if the rise was the difference or the amount traveled along the y-axis, well then the run, being left and right, needs to be the distance you've traveled along the x-axis, which in this case, from -1 here, 1, 2, 3, 4, along the x-axis to get from point 1 to point 2. And we can actually simplify this down. So this simplifies down to 2 over 1, which we know that any number over 1 is a whole number. So we have a gradient of 2. But there's got to be an easier way to do this because we're not always going to be working with such small, manageable numbers. How do we do it when we have bigger numbers? Well, we can still use rise over run. We just need to come up with a new formula for it. And so here's what we do. Let's rub all of these out and actually come up with our proper formula. Well, our rise, we found the difference between our two y-axis values. So we're going to take the second value, that's going to be the end point, the last point, which is our y2. And from that, we're going to subtract our y1 value. That's our start point. And believe it or not, we're just going to do exactly the same thing with our run value as well. So it's going to also be x2 take x1. And this becomes our new formula for gradient, rather than actually having to sit there and count 1, 2, 3, 4, 5, 6, 7, 8, because you don't want to get to Cartesian planes that have an x-axis and a y-axis in the hundreds and counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up there. You don't want to be doing that. You want a quicker way to do it. So our next line, if we take our y2 value, well, we can see over here our y2 value, that's 5. Take our x2 value, sorry, our y1 value, which over here is negative 3, over our x2 value being over here, which is 3, take our x1 value, which is here, which is negative 1. Well, now, I know that 5 take negative 3, that's going to be 8. And 3 take negative 1, that's going to be 4. And we're left at the same result. We still have a gradient of 2 over 1. Now, what this tells us when we have our 2 over 1, which is rise over run, it's actually telling us that from our start point here and any point along this line, or even further if we need to go, if we rise by 2 and we run by 1, we're going to come back onto the line. Rise by 2, run by 1. Rise by 2, run by 1. It will continue along. Even when you get to this point here, if you want to continue the line, rise by 2, run by 1, and you'll get to another position that'll be on that line. That is how we calculate gradient. As always, I hope this video was useful. If you have any questions, please do write them down, bring them into class and ask your teacher. I'll bet they'll be able to answer all of your questions about how to find the value of the gradient. See you in class.